Hello, I'm Sarah Mikesell, and I am here as your host for this podcast with the Pig Site. And today we're here with Greg Page. He works with Trouw Nutrition R&D. So thanks for being with us today, Greg.
Thanks, Sarah. It's a pleasure to be here. Maybe just a little bit about myself, because I'm sure your readers or your audience hasn't really heard of me before. And that's largely because I come from a background that is a little bit broader. I have a background in fish and poultry nutrition, and only recently in the last 3 years have been involved in swine nutrition, leading a global team of about 6 researchers and 5 technicians that conduct our global Trouw portfolio. So that's my role, is to really help guide and execute Trouw Nutrition swine research portfolio.
Very good. And where are you based at, Greg?
I'm based between 2 offices, actually, in the Netherlands. We have a head office in Amersfoort, which is more of a hub, if you will, whereas the Boxmeer office, which is more in the southeast of the Netherlands, is where our research office is, if you will, and very close to our swine research facility.
Oh, very good. That's exciting. It's nice to be near the research, I'm sure, for you too, in this world that we're living in, right, where we're all working from home a lot, needless to say. So
exactly. No, it's nice to get out into the barns and see the animals and really get a hands-on feel for how the studies are going, and really see what's actually going on in the studies. It's one thing to get a piece of paper at the end of a study to know what things happened. It's another thing to actually see it in person.
Very good. Very good. Well, it was great. Thanks for sharing a little bit of your background and what your role is with our audience today. Let's dive right in, I guess, to our topic. And we kind of mentioned the pandemic and COVID, and I think that has really made the whole world really acutely aware of immunity and what a large role that it has to play in maintaining our health, animal health. It's really a key component, needless to say. But let's talk a little bit, Greg, about what do we really mean when we talk about immunity?
Well, that's a good and unfortunately a very tough question, because we're really talking about biology here. And everything in biology is more complex than we'd like it to be. Sure. And immunology is actually its own scientific discipline with its own language and terminology, which makes it a little bit obscure for most people, because it isn't, how do we say, it's not the typical area that people explore. But that being said, when we really talk about immunity, we're really classifying about 2 things. We're talking about 2 categories of immunity. We talk first about the innate immune system, and then we talk about the adaptive system. So if we're talking about the innate immune system, it's really what we call the most basic system of protection that animals, including humans, have. And it really involves the things like the physical barriers to infection. So things like the skin, the mucous membranes, things like saliva, tears, mucus, and we talk about the digestive tract. But it also involves other, what we call maybe less specific approaches to disease prevention, things like digestive enzymes and acids that we secrete during the digestive process. And it also has physical responses, such as peristalsis. That's the movement of the gut tissue that moves the digesta throughout the digestive tract. And what this does in cases of diarrhea, for example, in humans, we've all experienced that when we've had the flu, for example. That's a way for the body to react and flush out the pathogens. And so that can also affect the overall gut microflora. So that's the first part. And when we talk about the innate immune system, there's things that we all recognize. So inflammation, for example, is really a non-specific response, an innate response. And it's well-established mechanism. We understand it quite well. We all know about white blood cells, mast cells, among other examples of tissue, of cells within the immune system. And what they really do is they monitor through a tissue damage system and what we call inflammatory mediators that signal other cells to aggregate to the site of infection. And then they cause a cascade of reactions that we call inflammation, which is the swelling and the redness, if you will.
Right.
So when we talk about these signal molecules, we might recognize some of those. So we talk about histamines, antihistamines, when people have allergies, for example, and prostaglandins. These are things that trigger the local inflammatory reaction. And they actually attract other cells that release compounds called cytokines that are signaling molecules that help regulate the development of other immune cells. And then these cytokines, the signaling molecules, are roughly divided into those that enhance cellular immune responses, what we call things like examples, tumor necrosis factor alpha, interferon gamma. Those are just a couple examples. And then the other category that really enhance antibody responses or the adaptive immune system. And those are things like we call interleukins. And there's a whole host of those, interleukin 4, 10, 13, and there's a whole host of others. And really what we're doing here is just really scratching the surface of some of the compounds that have an impact. So what we've really talked about so far is really just that initial phase of the reaction, the innate system. But when we're talking about immunity, most people think of the adaptive immune system, or what we call acquired immunity. And so this process really involves the production of antibodies. This is really when we're thinking about things like COVID and vaccination, we're talking about developing antibodies against an antigen, the antigen being the protein molecule, if you will, or a compound that is on the pathogenic virus, for example, or the pathogenic bacteria that the white blood cells recognize, and then they form specific proteins, those antigens, against to prevent further damage from that pathogen. So again, we talked a little bit about COVID being the most well-known example in recent memory. But if we talk about other diseases, there's a whole host of those that we could talk about. At least from the human health perspective. In the swine field, there's obviously a whole host of pathogens, porcine respiratory virus, PED, porcine epidemic virus. There's all sorts of pathogens in the swine sector as well that also could rely on either adaptive or innate immunity. So really, when we're talking about adaptive immunity, this is really the system that we're talking about when we're talking about vaccines. So, and what we're really talking about is a naive host, a host, as in the pig in this case, where they're really not protected to any particular pathogen until it's been exposed multiple times. And is a key reason why it's difficult to protect against invading pathogens is that there is limited defense to avoid some of these diseases on the first exposure without a well-functioning innate immune system. So it's really only when the innate immune system fails that adaptive immunity becomes much more important and relevant. So the challenge with the adaptive immune system is that it's actually very highly specific. It targets very specific proteins from a single strain of virus or bacteria. And that's when we develop what we call memory, or memory B and T cells that can mount a rapid reaction to prevent severe disease from recurring. But that only happens in terms of those B and T cells after the organism, the host, has been exposed more than one time. Because on the first time, they can't mount a memory response because they've never seen it before. And that's one of the reasons why we have such challenges with the adaptive system or using vaccines, is that the adaptive system takes time to response. And that can take anywhere between at least 4 to 7 days in humans, and probably similar time frame in pigs. And so that time spent is time lost from a production point of view for the animals. So this adaptive system is actually very relevant for piglets, as one of the components is the production of immunoglobulins. Those are the antibodies that I mentioned earlier to specific pathogens that the sow can actually transfer to the piglets during the farrowing process via colostrum post-farrowing. And that's the reason that colostrum intake is so critically important in those piglets, and that we've through research have established that we need at least 250 grams of colostrum per piglet as a minimum threshold to ensure good performance for piglets. So that's one of the key reasons why the adaptive system is important, not just for the piglets themselves in developing that response, but also from what we call passive immunity that is transferred from the sow herself. And it's this complex challenge, and that is why these two systems, both the innate and the adaptive, where they interact in very complex ways to help suppress and or enhance each other, and is actually a very active area of research currently in both human and veterinary research, particularly in swine.
Very good. And the innate part seems to me that it's all the things that are happening inside your body, right? I mean, it's just like a kind of how your body is responding, but it's the adaptive that we can more so manipulate. Is that right, Greg?
In a way, yes. I mean, the innate immune system we can enhance as well through various tools. So proper nutrition, for example, can enhance skin integrity, for example. There are things we can do nutritionally to enhance mucus production, for example. So we can enhance the innate immune system as well to a limited degree. But it is really the adaptive system that if we are looking to have permanent long-term protection against some of these pathogens, that's really the system that we want to try and tackle. And there are things that we can do nutritionally, perhaps to enhance some of the cofactors and responses. And we'll talk, I think, a little bit later about some of these factors. But it's not easy. Let's put it that way.
Yeah. So let's talk about those factors that can affect the immune system development in pigs, and kind of walk us through that, Greg.
Well, I think what we'll do is we'll kind of break it down, if we can,
Sure.
into maybe 4 key areas, at least from my perspective. One is the age of the animal, the nutritional status. Then we can talk a little about stress that the animal is exposed to.
Right.
And then the last one is really about the pathogen itself, is how much of the pathogen is being exposed to the host. So we'll talk about each of those in turn to kind of give our listeners a little bit of a flavor for what all this means. So if we talk about age as a function, and this is really related to the development of the adaptive acquired immune system versus the passive, what the piglet gets from the sow via colostrum and milk. So passive immunity can protect somewhat, but only as so far as to the pathogens to which the sow has been exposed and provided antibodies, those immunoglobulins, to the piglet. And this benefit is actually transient, which means that the benefit that it provides subsides with time. So they get very good early protection, but as the piglet develops, it actually declines, and that passive immunity provided from the sow actually almost completely disappears about 4 to 6 weeks after birth. So it really creates that window of opportunity where the adaptive system takes time to become active, if you will. So it's that development of the adaptive system really only starts developing after about 3 to 4 weeks of age. And this is really what we call the immunity gap between, that 3 to 6, 7, 8 weeks of age post-birth, where the piglet is really immune compromised, for lack of a better word, and where they're more susceptible to disease pressure. The second one is really about nutrition. So nutrition actually can play quite a good role in supporting the natural defenses through a variety of approaches. One example, for example, is the use of probiotics. I think everyone is fairly familiar. These are bacteria that can modify the microflora, if you will, the beneficial microflora, as we call it, that can populate the intestinal tract and prevent pathogenic bacteria from colonizing the digestive tract. So they basically displace the negative bacteria with the positive bacteria. And one of the challenges that we have with this is that there's actually over about 600 species, give or take, of different bacteria, at least that we know of and can culture, that are in the digestive tract. But it's really hard to define what a good profile looks like. And we're learning more and more about that as we go, and is an active area of research. But there's also a number of probiotics on the market, and they all have varying degrees of efficacy that highlight the need for more research to improve the consistency of the effects of some of these technologies. And those could be for a variety of reasons. So we could be talking about some probiotics are more thermostable than others through the pelleting process. So you may need a higher dose in order to colonize. It could be that the prebiotic components that we provide naturally through the diet are insufficient to ensure the growth of those probiotics. It could be the natural conditions are not right for those probiotics to produce because they're live. And that's what we mean by probiotics, they're live bacteria. And those bacteria don't have the right conditions to produce the enzymes and antimicrobial peptides and other things that help us to control pathogenic bacteria. So those are some of the challenges on probiotics. But nutritionally, there's actually other areas. So we can talk about things like organic acids, essential oils, and these category of bioactive products actually can help control bacteria through antimicrobial properties. And some of which have actually also been documented to stimulate the immune system response. So as well as having beneficial effects on the intestinal tract development. So what we mean by that is physical structural changes in the GI tract. So we could talk about tight junctions. So many people know about tight junctions, or maybe less familiar. If we think about tight junctions as the mortar between bricks. Mm-hmm. So if you have not enough mortar or between the bricks, you have leaky cells, if you will, where you can get what we call translocation, where bacteria can go from the gut right into the bloodstream to cause systemic issues. So we want to enhance those tight junctions, and some of these products have properties that enhance those, but they also have the other effect, which is increasing villi height or crypt depth. And those are really aspects that help to improve nutrient absorption. So they effectively increase the surface area for nutrient absorption. So those are just a few examples, and there's a whole host of other bioactives that are currently being researched, not only by Trouw, but by other companies in the market that are really looking to strengthen not only the physical digestive tract, but also enhancing immunity and preventing disease outbreak.
And Greg, I'm sorry to interrupt. I have written a few stories about this in the past, and I've heard people also talk about these junctions as kind of like the roof on your building or on your house, right? And if it's not put together right, you're going to have that leak, which nobody wants to have, right?
Yeah.
and all the damage, right? That's the whole point, is there's so much damage that can happen when that's exactly when that occurs. So yeah, just another example.
It's a good analogy. Essentially, it's all you can have a well put together roof that has cracks in it, or you can have a very, very leaky roof, and depending on the amount of leakage that you have more damage. And that's the aspect on the quantitative effects we're still learning about,
Yeah.
and what the cascade of effects are, because once you have a leaky gut, how many bacteria get in there, the type of bacteria that end up translocating, for example, can have quite a vast cascade of effects, as we talked about in terms of the immunological response the host animal has. And that's an area that is still being researched.
Yeah, and I hear a lot about leaky gut even in human health right now. I was just at the chiropractor's office and they had a whole, video going on about leaky gut in humans. So again, that we see a lot of this crossover, I think, between human health and animal health that continues to be being developed, right?
Exactly. So we have things like Crohn's disease, et cetera. We've talked about the wheat diet, et cetera, that is all about treating gut health. And it's all related to this concept of leaky gut.
Mm-hmm.
So it's there's very much an overlap. And I think there's lots of opportunity for us to learn from what's being researched in the human health world.
Yeah.
I think one of the challenges we have is that the regulatory environment is very different in livestock sector. So while we may find very effective compounds or drugs, if you will, in better terminology, in the human world, there are significant barriers to using those kind of technologies in the livestock sector.
Right. Makes sense. Right. So I didn't mean to interrupt. Please continue on. So
no problem. So we've talked now about age and we've talked about nutrition. The other interacting factor that has an impact here on the immune system is stress. And this is really a critical factor that we may be just beginning to scratch the surface on and really don't have a full understanding of what those impacts are. So we've all experienced that when we're stressed, for example, we are more prone to disease. So we all get colds, are more likely to happen when we're stressed and tired from overwork and life in general. The same is really true when we talk about piglets. So the issue is that weaning, that process of transferring from the sow to an independent pig that doesn't have access to the sow, can actually be stressful in and of itself, because we're separating them from their mother. And for lack of a better word, we're causing an emotional stress, if you will.
yeah.
But we're not just doing that. We're moving them into a completely different environment, from the nursery to, a nursery, the farrowing room, shall we say, to the nursery, different sizes of pens. So the moving stress, the handling of those animals, we're moving them into new pens with new pen mates from perhaps different litters, with different disease exposure. They're having to reestablish a new dominance hierarchies, for example. And then there's new housing and climate conditions. And then the last piece, as if that weren't enough already,
Right.
we're actually changing them from a different diet. We're changing from a liquid sow milk diet to a dry complete feed. And the dry complete feed versus the milk have completely different nutritional profiles.
Right.
And so all of these factors are going to interact and cause significant stress to those pigs. So what we're still not clear about is which is the chicken and egg, to use a different analogy, which is causing the challenges in terms of immune stress and the growth check that we see in pigs post-weaning.
Right.
Is it the stress itself? Is it the change in the sow, or the diet that the piglets are exposed to? Is it the combination? Those are things that we're still not fully clear about. So in piglets, though, when we talk about their stress, they're looking at, we've all heard of the fight or flight response.
Right.
And this really, this is a stress response, and that can be manifested in the piglet through a number of different physiological responses. So we can talk about increased heart rate, bronchodilation, essentially meaning more rapid breathing, glycogenolysis, lipolysis, sweating. Well, in case pigs don't sweat, they pant. And that can cause other factors, that are negative. So call it yeah. Oh, we're just escaped me for the second. But
Okay.
we can also talk about decreased motility of the digestive system. It can increase adrenaline secretion and cortisol, which is a stress hormone, just to name a few. And there's probably
Right.
a myriad others. And it's all of these things that can have an overall impact on the physiology of the piglet. And what is the ultimate consequence of these reactions is that the piglet is trying to overcome this stress. And what they're doing is, to overcome that stress, they divert energy or resources, whether that's energy, amino acids, minerals, etc.,
Right.
away from growing to maintenance, in order to maintain homeostasis, to maintaining the body temperature where they want it to be, to maintain the heart rate where they want it to be, to mount an immune response to make sure they want where they want it to be.
Right.
All of these things can end up having an impact, which is manifested in other ways, but also in reduced feed intake. And it's likely it's one of these key biological responses, which is why we see the growth check post-weaning. So all of these factors have an impact cumulatively on feed intake. And it's this feed intake that we as an industry, particularly in growing piglets post-weaning, is to mitigate the negative effect of that growth check due to low feed intake. So we are looking actively on how do we increase feed intake. We look at palatability enhancers, we look at mitigating stress, we look at mitigating pathogens, et cetera, all in a way to try and enhance the overall piglet's growth performance. Because we do know that the heavier the piglet at the end of the nursery phase, the better they grow in the grow finish phase, reduced days to market, better feed conversion, et cetera. So really what we're talking about is setting up the overall performance of the piglets, or of the pig in general, for the entire growth cycle,
Right.
by really focusing on in that first 2 or 3 weeks of life.
Right. Kind of that idea of if you have a strong start, you're going to have a strong finish, right?
Exactly. Yeah, exactly. In Trouw, we call that the Lifestart concept. So it's an active area of research that really looks to try to exploit some of the benefits of enhancing early performance for long-term gain.
Very good. And just talking a little bit more about these stress factors, how do you in research start to break that down? There are so many of them that you were going through, Greg, that these piglets are, in that weaning phase, right? That they're
Mhm.
really having to deal with. How do you break it down? I mean, I would think part of it is which ones are the worst, so you can try to help mitigate those and minimize the effects of those first, I guess.
Well, it's a good question. In fact, I don't know that anyone has an ideal model for doing that yet.
Right.
But that being said, and it's the process by which we do science, essentially, which is controlling as many factors as we can and
Hmm.
changing as few as we can to really understand and separate out which one is having a bigger impact. So
Right.
if we talk about stress, well, one of the studies we're going to be doing shortly, which is really just for fundamental understanding, is should we be looking at weaning pigs, for example, within a litter versus mixing pigs
Yeah.
at the nursery phase? And
Yeah.
that will help us to understand, is the mixing or the stress that we induce from mixing pigs causing some of this issue, for example.
Mhm.
So that's just one example. You could look at, and there's been some work done on that to try and understand what are the right weaning conditions in terms of temperature, humidity, and factors like that, and trying to optimize those. The challenge here is that when we do these studies under very defined conditions, such that we know the temperature and the humidity that the study was done in and the health status of those pigs. But if we change genotype, for example, and we change the health status, are those conditions still optimal?
Hmm.
And there's a whole amount of work that could be done in those areas to really optimize. That becomes almost a never-ending process, because if we look at the genetic advances that companies make over time, the
Yeah.
genotypes that we have today are very different from those that we
Right.
had 20 years ago. So that's where we have to continuously look to improve the overall management practices that we use in weaning pigs and in growing early piglets.
Very good. Well, I'll let you continue. I appreciate you answering that question because it seems very complex to break it down, I guess, is what I'm thinking. So
It's not as easy as we'd like, unfortunately. But again, as a colleague of mine is fond of saying, it's called job security.
very good.
So
I'll let you continue with your list here.
no problem. The last area I think that we were going to talk about is talking a little bit about the idea of pathogen load. And this is really directly links the risk of specific diseases, which are direct impacts, or to what we would call predisposition to disease. These are the indirect opportunistic diseases. Mm-hmm. So when we talk about the immune system, the pigs is underdeveloped. We talked about that immunity gap. Their ability to respond to different pathogens is actually decreased right around that time when they're highly stressed and have those limited amount of resources to mount a strong immune response. So with high levels of pathogens in the nursery, and whether that is due to farm-specific issues in terms of suboptimal hygiene processes, improper cleaning, disinfection, poor biosecurity, for example, cross-contamination, poor feed quality, or using contaminated grains, all of these things that can have a depressive effect on the immune system. Then you can actually have a higher risk for disease exposure to piglets. And it's one of the reasons why we encourage very strong biosecurity and cleaning processes to ensure that we have a successful start post-weaning. So we really look at what we call the interaction between the feed, the farm, and the health. So health is really the immune response and what we can do nutritionally to enhance that, whether that is through the right balance of nutrients, but also gut health enhancing feed additives, for example. We can talk about the feed, which is really the nuts and bolts, ensuring that you have high quality, highly digestible with the right balance of nutrients. And the last one is the health aspect, or the management aspect. That's the farm component, which is really biosecurity, cleaning, disinfection procedures, environmental control, all of those things. And those all three interact to combine to make a successful start to the piglets.
Very good. That's a great synopsis, I think, of all of those factors really that kind of go into piglet, immunity, Greg. And there's a lot in there. We could do like a segment practically on every single one of those topics that you've talked about. So we'll have to think about that for the future, but we'll keep kind of moving on through our discussion here. And we think about immunity. Obviously, you've talked a lot about vaccination. And I guess one of the questions that always comes up is, if vaccinations are so effective, why don't we use more of them? Why don't we have more of them? I'll let you respond.
Well, yeah, that's another very complex answer. And there's socioeconomic factors in here that we can talk about. But let's start maybe from the beginning, which is really about why we use vaccines. And we use them because they're very effective in preventing severe disease. The challenge is the vaccines are never 100% effective, but they have added value. Even if they're not 100% in preventing 100% of the disease, they will mitigate the negative impacts of those disease. So they will improve the relative survival rate. They will improve the average daily gain, feed conversion, and other factors, even if you don't have 100% protection and prevention of disease. The challenge here is that not all vaccines are created equal. And here we've known from COVID that, we have the Pfizer, Moderna, et cetera. But we've also heard that not all of them are the same. They don't all provide the same protection. And that's because vaccines are largely composed of different types of subunits, if you will. There's mRNA vaccines and protein vaccines, et cetera. So they all work slightly differently. But their essential goal is to stimulate that innate immune, not the innate, pardon me, the adaptive immune system that we talked about earlier.
Right.
So when we talk about vaccines, we're really, for the most part, I'm not saying exclusively, but a large part, we're really talking about vaccines against viruses. And we are talking about attenuated or live attenuated viruses. So what we mean by live attenuated means the vaccine contains the live virus, although the ability to instigate full disease has been reduced significantly.
Mm-hmm.
So what we're doing is we're doing a little bit of a dose in order to prime the adaptive immune system to develop those B and T cells that recognize the antigens, and then the host can mount an immune response to prevent full-blown disease. That's really what we're doing. So the challenge here is that bacterial vaccines are based on acellular components of the pathogen. Mm-hmm. So for example, a toxin that the pathogen produces. And those antigens don't often elicit the strongest adaptive immune response. So that's why, for example, for some bacterial diseases, there aren't very good vaccines out there. Mm-hmm. So we know E. coli, one of the biggest causes for post-weaning diarrhea in pigs, has been around for as long as pigs have been around. And we've been researching E. coli for decades, and we're still no closer to having a really good vaccine, although there are some good developments in the pipeline. But despite some of these differences in vaccine types, the reality is that for some diseases, we just don't have them available. Mm-hmm. One could be that the cost of developing those vaccines are extremely expensive. And if they don't provide adequate protection, then relative to the cost, no one's going to adopt it. The cost of development, just not the science of developing it and validating that it works. They also have the regulatory component. It's extremely difficult to get vaccines and other drugs approved for the livestock market. And in a lot of geographies, they require different data. So what you register in the EU, for example, may not apply to registering in the US or in South America or in China. And so that creates higher costs for some of these drug companies in developing these vaccines. If we talk about where and when we apply them, again, because vaccines take a while to develop, by the time the animal develops an immune response, maybe the window of opportunity is already gone, because some of these pathogens are so effective in killing their hosts that by the time an immune response is mounted, you've already lost 50% of your herd. So that creates some challenges. But there are new vaccines being developed, and some are administered to the sow. And similar to what we talked about in colostrum and transferring some of these immunoglobulins, they can transfer some of that passive immunity to the piglets. But as we've learned before, some of that is transient. Mm-hmm. Some other vaccines have to be administered to the piglets in several doses for them to be effective. So if we look at the COVID vaccine, for example, depending on which one you get, you have to have 2 doses. So I had the Pfizer, I had 2 doses, but they've already warned that depending on what variant you get exposed to, you may need a booster shot in order to get that. So when you start looking at those pragmatic aspects of applying vaccines to pigs in livestock production, mm-hmm. that actually adds a whole host of problems, such as added handling and the stress that brings to the pig, mm-hmm. in addition to multiple doses and costs of the labor to inject all of those animals. And that isn't always readily available. I think if you talk to the industry as a whole, I think most of them would say that we don't have enough labor in order to do some of these things. So there's some challenges there if we start talking about vaccines as a whole. And again, depending on which disease we're talking about, The time for the pigs to develop that full immune spectrum is sometimes longer than the productive lifespan of the animal. So some of those vaccines can be of limited use effectively to be used in the industry. So like I say, there's a host of challenges there, and is one of the reasons why we don't have a huge number of those. And probably why we spend more time and effort vaccinating for very infectious diseases for which we have good solutions that can be administered a single time very rapidly at times when we are already handling those animals, such as right after birth, when we're doing the tail docking, ear tagging, etc. We can administer that very quickly, which doesn't add a huge amount of extra time and labor. And in some cases, we also spend a little bit more on the animals that are more costly, such as the sows, because they have such a long productive cycle.
Right. That's what I was just thinking when you said that before, that vaccines for piglets maybe don't make sense because of the life cycle, but maybe that's where, that's where the sow comes in as well. That's a better use of vaccinology, I guess, and being able to get the most out of it is through the sow herd, and hopefully get some passive immunity through that as well, right?
That's the goal, and I know that there is currently an E. coli vaccine that is currently being trialed, I think, for sows for passive immunity transfer to the piglets. So I'm holding
Right.
out a lot of hope
Yeah,
for the industry that will
that'll
ultimately
work.
mean less disease.
Yeah, that's great. So when we think about this gap potentially, how can producers minimize that impact of this immunity gap, Greg?
Well, I think there's a number of things that producers can do. If we talk a little bit about that holistic approach that I was talking about, the feed farm health concept, and we talk about the farm operation, we can look at a little bit about biosecurity measures, setting up routine cleaning and disinfection procedures throughout the year, minimizing stress by ensuring that you have the right quality control, climate control, pardon me, measures in place, that you have good water quality management. We don't often talk about water quality because we often are on a well or we get water from wherever we can. We don't really look at it because that's what we have. But there are things that we can do to control water quality, whether that's acidification or other things that can help with overall reduction of pathogen load. We can talk about a sound health management program, having a good relationship with your local veterinarian in order to understand what disease pressures are in your local area, setting up a good vaccination program for those diseases that we have solutions for. But we can also talk about farm management from the sow perspective, all the way through to the nursery to minimize cross-contamination risks.
Mhm.
So we can talk about feeding very high quality feed, with a good sound nutritional profile that is actually tailored to your specific operation. And what I mean by that is we know that different genotypes grow differently. And those genotypes, and depending on the health status of the herd and the raw materials that are available in any particular geography, change the economic profile. And so you can actually tailor the nutrition that you're providing to your specific farm based on all of those factors by working with your feed company and your veterinarians to really improve the overall health and profitability of your herd. So those are some of the things that producers can do on their own.
And I guess let's talk a little bit about nutrition specifically, and what can we do to improve performance from a nutrition standpoint during this difficult phase for piglets?
Well, I think one of the key challenges that we have when we talk about immunity in piglets is that they're mounting an immune response can actually fundamentally change the nutrient requirements of the pig. So we talked a little earlier about how, for example, when they're mounting an immune response, they're diverting energy away from growing to
Right.
what we call increased maintenance requirements. So maybe they need that extra boost of energy, for example. And this is actually an area that's a lot of people are researching now. and looking at, well, what other requirements are there beyond just energy? Do we need to alter, for example, the amino acid profile to support the production of antibodies? Do we need higher vitamin or trace minerals in order to support that immune response? So those are new areas of research, and we don't fundamentally understand all of them. And understanding some of these interaction can actually alter how we would balance the diet, the nutritional profile of the protein, for example. Are there specific amino acids that are particularly important in the immune response? And there's some new research that suggests amino acids like threonine, arginine, glutamine, among others, are more important. So maybe our standard approach for the ideal protein profile needs to change in response to the health status of the herd. So while I said that the whole area of nutritional immunology, that's actually a subdiscipline of immunology in particular, is actually still developing. And my expectation is that there'll be a number of interaction effects that will come up between various nutrients and how we balance the supplementation of those nutrients through various additives or ingredients to our diets. That will help influence the animal's response and consequently their requirements, if you will. And that's actually one of the critical areas of active research that we're looking at to try and establish that good start for piglet growth, to ensure that lifetime performance and the true genetic potential of modern genotypes is fully expressed. But one thing that hasn't really been investigated, at least to my knowledge, is really the interaction between some of these different additives and their effects on the host. So we supplement these additives to look from a very, very specific point of view, which is feed intake, growth, mortality. But we really don't fundamentally understand the dynamics of what that is doing to the host. And we know that the digestive tract in and of itself is the largest immune organ in the body. And so understanding the interaction between the host, the gut, the microbiome, and the immune system is an area that is really developing. And we also know that in some cases there can be too much of a good thing. So where we can overstimulate the immune response. And what that does essentially is it's the same thing as causing a disease in many ways, where the piglet is actually trying to mount an immune response. And so it's reducing growth in order to meet the needs for mounting that immune response. So, and obviously with, if protein and energy are key in those immune responses, those are the two single costliest nutrients to provide in a diet. So, you know, we're talking about factors that can have an impact on the cost of production. So really making sure that we balance the stimulation of the immune system to prevent disease while not overstimulating, so that we don't end up costing too much in terms of mounting that response in pigs. So overall, I would say it's really immunity and nutrition is really quite a complex area that we as an industry are still trying to learn about.
Very good, Greg. This has been enlightening. I feel like we all feel like, having gone through COVID, that we're all immunologists, right? Because we've heard so much about vaccines and vaccine development and how it works and all that kind of stuff. And we get caught up a little bit in hearing things from different places. And it's really nice to kind of have somebody put it all together and really start from the beginning and walk us through that. So we really appreciate all the information today.
Well, my pleasure for being here. And again, if you want to learn more, there's plenty of information out there. The challenge is, again, putting it all together and making it into a simple message. I hope I've tried to break it down, but it's much more complex than I've even attempted to do here. And as I say, I'm a nutritionist by training, not an immunologist. So This is an area that still, for nutritionists, formulating and balancing diets is an area that we're still learning a lot about.
Very good. Well, hey, thanks again, Greg. We really appreciate it. And this is Sarah Mikesell signing off for the Pig Site.